Hello, and welcome to the fifth uRTcmix tutorial video, the uRTcmix computer music language embedded inside the Unity AR/VR development environment. In this tutorial, we're going to use the uRTcmix LOCALIZE instrument to do sound localization and spatialization. In the 3D environment, it's not too difficult, but there's a little bit of a trick. That's what I want to show you. All right, so I've created a very simple scenario here where we just have a sound source that's going to be making some beeps and then a sound listener and observer over here. Now, the only thing I've done of note is I put the main camera as a child of that observer. That's so that I can move the observer around and have the camera move independently. That's important when you're using VR and AR goggles. Now, the basic setup is really simple. I just have the sound source is using the script called beeper sound. It's just a very simple uRTcmix script. It starts out generating a bang in the start method. Down here, it sees the bang, creates a wavetable sound, a sine wave, for 1/10 of a second long, the G above middle C, and then reschedules itself 2/10 of a second after that. So every 2/10 of a second, it'll make a 1/10 of a second beep. And we can hear that. Here we go. And I can move around. I put a little movement script onto my observer. And notice that as I move, though, if you're listening with headphones, the sound isn't really changing at all. It's just being played out into the stereo sound field. We can change that using LOCALIZE. Now, before I show you what to do, I want to talk about how it works. It uses a technique called audio ray tracing, where we have a sound source, and what LOCALIZE does is calculate the distance from that source to each ear of my stereo listener. Then based on that distance, it calculates the delay time with the speed of sound and air and the amplitude fall off with the distance. Your ear and brain use that information to decode where sound is localized. So you think, okay, simple. We'll just create a script on the listener that will identify the source, calculate that delay. But the problem is we don't want to do that on the listener. What if we have multiple sources? What if new sources are coming into the field of view as we move the listener around? All of a sudden, this becomes very complicated for the listener to disambiguate all of these different audio streams. The way that LOCALIZE works in Unity is that we will actually calculate these delays at the source and apply them before we play them out into the world. And that's fine because that's making the sound. We might as well do all the processing there. Now, to do this, we're going to use a capability of Unity where we can designate the listener. Oops, that's the wrong one. Let me get this going. As the center of our coordinate system. And we're going to use that kind of made-up coordinate system to determine where the source is relative to the listener. That makes it very simple to do the calculation. The other thing this does is that if we move our head around, which is important for doing source tracking, we can simply rotate the coordinate system and recalculate the source coordinates based on that 0, 0, 0 kind of destination. So let's go ahead and set that up. I'm going to start with a different scene here. All right. And now the observer is the same, still has the main camera, but we've added one thing to the main camera. There's a script attached to it called getMyTransform. All I did with that script was grab it from out here, drag it into here, showed up in my assets, and I put it onto the camera. That's the thing that allows me to figure out here what the coordinates of are relative to the 0, 0, 0 base here. Again, it sounds complicated, but to use it is really, really simple. In fact, let's just do that. Let me start up our script editor here. All right. And I've already added a few things that we'll talk about in a second just because I didn't want to do too much typing. But we're going to go and we're going to do this. And we're going to say getMyTransform. And we'll call it myRelativeTransform. Okay. And we're going to have to then locate that, which is pretty easy to do. We'll simply say myRelativeTransform equals, and we'll call it camera main get component, and the component we're going to get is get my transform. Okay, so we can now use this to get what my coordinates are for the sound source. All right, now here's how we're going to use it. Down here, I've now, in addition to doing the initialization with the max bang, I've created a setup where I'm configuring the wavetable to send its output via this bus config into the localize instrument. And then the localize instrument will play it out. Now, I've also set up a couple of variables within localize using p-field inlets. This is how I'm going to get the data from my current location into the localize instrument. Now, what are all these parameters? It looks kind of scary, the localize instrument. Well, let me show you. Okay, a lot of them are very basic. Output, skip time, input, skip time, duration. You know, that's just, we're going to start at time 0 on both output and input, and we're going to let this play for a real long time, basically as long as the game is running. All right, that's the amplitude. We're just going to say 1. You know, we're going to use the basic amplitude. And then there's 3 triples. There's the source X, Y, and Z triple, and the destination X, Y, and Z. Now, we already know the destination is 0, 0, 0, because that's what we set up as the base of our coordinate system. Now, the X and Y source, we're not going to use the Z source. Those are the coordinates of this sound-producing object. And we're going to feed those in, like I said, through a make connection. Very simple to do. The rest of these, this is just some information about how wide your head is, how many feet per unit in the Unity environment. And then importantly here, this is the input channel that you process. Localize only does one channel at a time. So if you have a stereo sound source, you'll have to set up 2 different localizations, and you might want to actually spread the left and the right signals out. It's entirely up to you. And the rest of this is just information about the type of processing and delay that it will do. All right, so that's basically it. But we do need to set up this kind of sort of localization stuff here. So let's do this. Let's say that my current position, my current, we'll call this vector 3, my position. We're going to set that equal to my relative transform dot get transform. And we're going to give it my game object here, which is the current object. Now I have my position vector that has the X, the Y, and the Z coordinate of this object. So what I'm going to do is I'm going to say uRTcmix dot set p field. Okay, and we're going to basically set the first inlet, which is the X coordinate. We're going to make it be my position dot X. Okay, and we're going to send that to obj_no. And then we're going to say uRTcmix dot set p field uRTcmix. The second inlet that we set up there, my position. Now we're going to do something tricky here. Dot Z to the obj_no. Why did we do that? Well, because localize uses an XYZ coordinate system where the XY plane is the flat plane. That's the way Blender does it also, by the way. Unity makes the XZ plane the flat plane. So we have to swap the Y and the Z coordinates in this case to make sure that we're, basically referring to the location that we want in the 2-dimensional plane. Like I said, we're not doing 3-dimensional here. Okay? That's all there is to it. Once we have set that up, when we make our wavetable, it will go through that localization instrument. It will basically set its coordinates, get its transform relative to the listener object, and there it is. So now we can go back out here, and we'll play it, and you'll hear. Now, as I rotate, if you're hearing with headphones, you'll notice that it's localized. If I get closer, it gets louder. I can move around behind me. Okay, I can back away from it, and it'll get softer. So basically, we have now spatialized our sound source. Okay, just to go through this, if you're using LOCALIZE, you just have to do the following things. 1, create your sound source. Oops. 2, create your listener / observer. Put the main camera on it. 2a will say, add the get my transform.cs script to the camera. Okay. Then set up the LOCALIZE uRTcmix instrument. I can't spell here. With bus config so that it is receiving the audio from the source. And then 4, oops, didn't spell that right either. Okay, 4, then we will create p fields to receive the sound source coordinate data, update that data as the situation moves in the update function. And then it all works. That's all you need to do.